A piecewise-defined function is a function that consists of two or more formulas. For example, f of x equals x if x is less than 0, 2x plus 1 if 0 less than or equal to x less than 2, and x squared if x greater than or equal to 2. This is a typical example of a piecewise defined function. In this case, this piecewise function has three pieces or three formulas. To approach a piecewise function, we should always consider the restricted domain. In this case, there are three pieces, three formulas, and so there are three separate domains. On the real number line x going from negative infinity to positive infinity, we would cut this into three pieces because there are three formulas, and we would label the break values. In this case, x is less than 0, meaning that x goes from the left negative infinity all the way to 0, and then the middle piece go from 0 to 2, and then the last piece is when x is greater than or equal to 2. With the piecewise functions, the formula is only defined on the restricted specified domain. In this case, on the left-hand side of 0, the formula is y equals x. Between 0 and 2, 0 included, the formula is y equal to x plus 1. And on the right-hand side of 2 included, the formula is y equals x squared. When we evaluate a piecewise function, we have to pay attention to the domain. So for example, if we want to evaluate f of 1, which piece do we use? In this case, the input is 1, so it lives in between 0 and 2. We have to use the piece 2x plus 1 to evaluate this function. If we're asked to evaluate f of negative 2, then negative 2 is on the left-hand side of 0, so we have to use the first piece, which is f of x equals x or y equals x. So we plug in negative 2 into x. F of negative 2 is negative 2, and so on. To graph the piecewise function, we only graph the parts that are in the restricted domain. In this case, from negative infinity to 0, 0 to 2, and then 2 to infinity. On the left-hand side of 0, we only graph y equals x. Now the line y equals x would go from the left to the right and would go through the origin. But remember that we only graph y equals x on the left-hand side of 0. We only graph a part of y equals x on the left-hand side of 0. When we get to 0, we would have to use an open circle because 0 is not included in this formula. If we want to exclude it, we would use an open circle. Next, we would graph 2x plus 1, but only between 0 and 2. When x equals 0, 2 times 0 plus 1 is 1. And so one point on this line is y equals 1. Even though 2 is not included in the second formula, we can simply interpret it as an endpoint. So if we pretend to plug 2 in there, we're not supposed to, we see that 2x plus 1, when x is almost 2, is almost 2 times 2 plus 1, which is almost 5. And so we would have another point, but again, 2 is not included in the domain, and so we would have to use an open circle. 0 is included in the second formula, so we would use the filled-in circle. And this is a line, so we would just simply connect the 2 points to form the line, which is the graph of the second piece. or second formula. To graph the last piece, we noted that this is y equals x squared, which is a parabola, and 2 is included in the restricted domain for this parabola. When we plug in 2 into this last formula, we see that 2 squared equals 4. And so 2 is included in the domain, and so we would use the filled-in circle. This is the graph that is part of the parabola, but it only on the right-hand side of x equals 2. On the graph, we see that there are 3 pieces corresponding to 3 formulas for the piecewise defined function.